A large language model is like a brilliant student who has already graduated. It can reason, explain, and write beautifully, mastering patterns of language and logic. However, it has one critical limitation. It can't look things up. When you ask it to reason without evidence, it will guess, leading to confident but completely wrong answers or hallucinations. LLMs are pattern completers, not databases. They don't inherently know your documents, and they won't update when your data changes unless forced to check sources. RAG is what happens when you stop asking AI to remember everything and instead teach it how to look things up, leading to a grounded answer rather than a hallucinated one. The solution is an open book exam for AI, known as Retrieval Augmented Generation, or RAG. We don't try to make the students, quote, smarter. We simply give them better tools and a simple rule: read first, then answer. This involves providing a library, a retrieval system, and enforcing the rule to read before generating an answer. RAG works by separating responsibilities. Retrieval finds the facts by scanning the library and pulling the most relevant pages, responsible for selection. Generation explains them. The LLM's only job is to read the selected pages and write a coherent answer, responsible for reasoning. This separation forces humility. The model cannot speak until it has read the evidence. The RAG process begins by preparing the library, where we break documents into, quote, chunks. A chunk is a paragraph-sized idea, similar to highlighting a textbook. Chunking is a core trade-off. Chunks that are too big pull in noise. Chunks that are too small risk losing context. Chunking is deciding how much a model should read at once. Chunks are organized by meaning, not keywords, using embeddings. An embedding turns text into a coordinate on a meaning map, grouping chunks with similar meanings. The user's question also becomes a point on the map. We then find relevant information by grabbing the chunks closest to the question, similar to searching for songs like this one on Spotify. The RAG pipeline is a disciplined, four-step process built on this foundation. First, we store knowledge. Documents are turned into chunks, embeddings, and saved in a vector store. Second, we find relevant pieces. The question is embedded, and a similarity search returns the top chunks. Third, we attach to question. The chunks and question form the context. Finally, we generate answer using the LLM. It's critical to clear up misconceptions about RAG. RAG is not memory. The knowledge is ephemeral. It's not just search. RAG gives you answers, grounded in documents. Most importantly, RAG doesn't make the model smarter. It makes the model better informed by providing it with better notes. RAG versus fine-tuning. Fine-tuning teaches the model how to speak, shaping its style and behavior. RAG teaches the model what to read, supplying knowledge. RAG wins when knowledge changes frequently, sources must be cited, and cost is a factor. Fine-tuning is better when a consistent style is needed and the knowledge is stable. RAG usually fails for one of three reasons. Bad chunks means the retrieved text is too noisy or misses key context. The fix is to chunk ideas, not pages. Wrong retrieval means the librarian didn't find the existing information. The model can't answer what it never saw. Too much context overwhelms the model's ability to reason. RAG is about selective reading, not maximum reading. The one mental model that explains everything is that RAG turns the LLM into an open book exam taker. A closed book exam risks hallucination. An open book exam leads to grounded answers. But if you give the student the wrong pages, you will still get the wrong answers. Here is the 60-second explanation of RAG. Large language models are good at reasoning but bad at remembering specific, up-to-date information. Retrieval Augmented Generation fixes this by letting the model look things up before answering. The system finds the most relevant pieces of your documents, attaches them to the prompt, and then the model generates an answer using only that information. It's basically an open book exam for AI. This diagram captures the entire RAG philosophy: find first, then explain. Relevant excerpts are retrieved from your documents and passed to the model, leading to a grounded answer. Here are final soundbites for your teaching toolkit. RAG is open book AI. It doesn't make models smarter, it makes them better informed. Retrieval finds facts, and generation explains them. If the model didn't read it, it shouldn't say it. You are now ready to design good RAG systems. The RAG triad is your AI's report card for evaluating accuracy and relevance. The problem is the, quote, confident liar, which hallucinates or uses irrelevant context. The solution uses three metrics: context relevance, groundedness, and answer relevance. These check if retrieved documents are relevant, if the answer is supported by the context, and if the final output addresses the user's query.